Good morning, children. This is the mathematics session for class 9 and we are continuing polynomials, and today's topic is algebraic identities. Already in our previous class we have learned three identities, that is x plus y whole square is equal to x square plus 2xy plus y square, x minus y whole square is equal to x square minus 2xy plus y square, x plus y into x minus y is equal to x square minus y square, x plus a into x plus a into x plus b is equal to x square plus a plus b of x plus ab. Today we are going to learn three more identities, that is x plus y plus z whole square, that is a square of a trinomial. When a trinomial is multiplied by itself, the process of multiplication takes lot of time. Instead of that process, we can substitute the first term as x, second term as y and third term as z and perform the multiplication easily. So, to perform such multiplications or to perform the multiplication of a trinomial by itself, we use the identity x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. That is, the first term is the square of first term, second is square of second term, then square of third term, plus twice the product of first and second term, plus twice the product of second and third term, plus twice the product of third and first term. Similarly, we are going to learn two more identities today. In that, the second one is x plus y whole cube. That is, when a binomial is multiplied by itself 3 times, it takes lot of time to perform the multiplication. Instead, you can substitute your values of first and second term in place of x and y and perform, or you can get the product easily. That is, x plus y whole cube is equal to x cube plus y cube plus 3xy of x plus y. When we open the bracket 3xy of x plus y, we get it as x cube plus 3x square y plus 3xy square plus y cube. Again, another identity is also a cube of a binomial, but the sign in between is minus. In such a situation, the product is x cube minus y cube minus 3xy of x minus y, or when we open the bracket, we get x cube minus 3x square y plus 3xy square minus y cube. See children, in the first step, y cube is beside x cube, and in the last step we have written it last. We have written it to remember the formula easily, that the first is plus minus plus minus. Formula is same for above and below, but the signs are alternate. So now let us see how to apply these formulas in the problematic situations. The first question is, write the expanded form of p plus 2q plus r whole square. Expanded form means nothing but the product of this trinomial by itself. It is in which form? A plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca, where a represents p. Instead of a, we will replace a by p. Instead of b, we replace 2q, and in place of c, we replace r. So we get p square. And in my last class only, I told you that whenever any variable is there with a coefficient, we have to write it inside the bracket. Otherwise, the square will only come for q. Now the square is for both the terms 2 and q. So, the answer is p square plus 2q square plus r square. This represents a square plus b square plus c square. Now, 2ab means 2 into p into 2q, 2BC means 2 into 2Q into R plus 2CA means 2 into R into P. So finally the product is P square is P, and in 2Q square, 2 square is 4 and Q square is Q square. R square plus 2 2s are 4PQ plus 4QR plus 2PR. So once again I'll read the final answer. The square of P plus 2Q plus R is P square plus 4Q square plus R square plus 4PQ plus 4QR plus 2PR. Now similarly one more problem is there, 4x minus 2y minus 3z whole square. Here instead of B the term is minus 2y, instead of C the term is minus 3z. Here also we'll use the same formula, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So instead of a square we have written 4x square, instead of b square we have written minus 2y square, instead of c square, in place of c square we have written minus 3z square plus 2 into 4x into minus 2y plus 2 into minus 2y into minus 3z plus 2 into minus 3x into 4z. So the final answer is 4x square is 16x square, minus 2y square is plus 4y square, minus 3z square is plus 9z square, and here the fourth term is plus into minus, plus into plus plus, then plus into minus minus. So 2 4s are 8, 8 2s are 16xy, and here 2 minus signs are there, so it becomes plus. Again 2 2s are 4, 4 3s are 12yz, and then the last term is minus 2 3s are 6, 4s are 24xz. And the third one is factorization that we will be doing in our next lesson. And now the next we will be using a plus b whole cube identity and a minus b whole cube identity in this problems. X plus 1 whole cube. This is nothing but cube of a binomial. So it is in which form? A plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. So we will be replacing a by x and b by 1. So x plus 1 whole cube is equal to x cube plus 3x square into 1 plus 3 into x into 1 square plus 1 cube. Children, by mistake I have printed here y cube. You write down y 1 cube. So the final answer is x cube plus 3x square plus 3x plus 1. Nobody should write y cube in the second step. Should write 1 cube, children, because y is equal to 1. Now the second question is in the form of a minus b whole cube. Here we will replace a by 3 and b by 2. Why we are not replacing by minus 2? Because the formula itself is a minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. So a means a cube means 3m whole cube minus 3a square b means 3m square into 2n plus 3ab square means 3 into 3m into 2n square minus 2n cube. 3m cube means 3 cube is 27 and m cube is m cube itself. Again here in bracket 3m square means 9m square and 2n square means 4n square, and 2n cube means 2 cube is 8 and n cube is written as n cube. So the final answer is 27m cube minus 3 9s are 27, 27 2s are 54m square n plus 3 3s are 9, 9 4s are 36 mn square minus 8n cube. Third one is factorization question that I will be solving in the next lesson. And now few factorizations we will be doing today. That is, factorization is the reverse of finding the product. Reverse of the identities. Here you have to observe the product. It is in which form you have to observe it carefully. And if it suits our identity, we can directly write the formula and write its factors. So let us see how we apply factorization in our problems. The first question is 6x square plus 19x plus 15. Here the x square term is 6. It is not a perfect square. And third constant term is 15. It is also not a perfect square. So this question is not in any form of identity. So like 8th class, we will be finding the factors. We will multiply the coefficient of x with the constant term, that is 15 into 6 is 90, and we will find the factors of 90 such that the sum will give the middle term. 15 6 are is 90 and 10 9s are is also 90 children, where 10 plus 9 gives 19. So instead of 19, remaining all terms I am keeping as it is. Instead of 19 I am writing 10x plus 9x, only 19, didn't change any value. The sum is as it is because this is a process to multiply a constant term with coefficient and then find the factors of those 90. For 90 will not have only two factors children, 10 and 9. It will have so many factors, but we have to select such factors whose sum or difference according to the need is the middle term. So we have replaced, second step is 6x square plus 10x plus 9x plus 15. Remaining the two terms are same. Instead of 19x I have written 10x plus 9x. Now 6x square and 10x square, for 6 and 10 the common factor is 2. When I take out 2x common, 2x into 3x is 6x square. So out of 6x square I have taken 2x square outside and remaining 3x square is inside. Out of 10x, if I take out 2x, that is 2 into 5 is 10 and x is coming out. So 2x when comes out, only 5 remains in the bracket. So this is known as taking out 2x common. When 2x is taken common, in these first two terms, the remaining terms inside are 3x plus 5. When you multiply again these two terms, you get the above problem. Now see the third and the fourth term. Both 9 and 15 comes in 3 table. So we'll take out 3 common. The terms that are remaining inside are 3x plus 5. Again, now we have two terms. In both the terms 3x plus 5 is there. So we'll take that 3x plus 5 common. When we take out 3x plus 5 common, 2x remains in the first term and plus 3 remains in the second term. So this 6x square plus 19x plus 15 is the product of two binomials 3x plus 5 and 2x plus 3. Factorization means, suppose 90 is there, the factors are 10 into 9, 45 into 2, anything. In the same way, for this trinomial, the factors are 3x plus 5 and 2x plus 3. Please do this is 10m square minus 31m plus 50. Again, the coefficient of m square is not a perfect square. 15 also is not a perfect square. So you cannot apply any identity. Again, we will multiply coefficient of m square with 15. When the coefficient of m square 10 is multiplied by the constant term 15, we get 150. And the factors of 150 such that their sum is 31 are 25 into 6 is 150 and minus 25 into minus 6 also gives plus 150. But if I need the middle term is minus 31. So according to the need, we will allot the signs to the factors. Because I need minus 31, here I did minus 25 minus 6. These problems we did already in 8th class. If you don't remember, practice this properly. Now, in the second step, 10m square is written as it is, but 31 we are writing as minus 25m minus 6m. Because we want to find the factors, we are finding the factors of the product of constant term and coefficient of m square. Then again in the third step, the first and second term comes in 5 table. So when we take out 5m common, inside remains 2m because 5m into 2m is 10m square. And 25, instead of 25 I am writing 5 because when I multiply 5 into 5m I get 25m. Similarly, in third and fourth terms, both the numbers 6 and 15, the common factor is 3. When I take out minus 3 common, minus 6m, it remains 2m. When we multiply minus 3 into 2m, we get minus 6m. Similarly, when we take out minus 3 common from 15, minus 5 remains inside. Thus, again now we are having two terms. 2m minus 5 is common. When we take out 2m minus 5 common, in the first term 5n remains, in the second one 3 remains. So, the factors are 2m minus 5 into 5m minus 3. Thus, a polynomial 10m square minus 31m plus 15 is obtained by multiplying 2m minus 5 and 5m minus 3. That's why these two are called the factors of the above polynomial. Now the third one is again, these are the coefficient of x square is not a perfect square. 2 is also not a perfect square. So same factorization will follow. 12 2s are 24. And we want the sum 11. So we cannot use 6 4s are 24 because 6 for 4 is 10. So we will use 8 3s are 24 as 8 plus 3 is 11, where we need that sum as the middle term. So second step is 12x square plus 8x plus 3x plus 2. What I did here? Instead of 11x, I have written 8x plus 3x. Again, first term, I'm sorry, the steps are interchanged. The last step is the third step. From first and second term, 4x is common. And inside 3x plus 2 remains, and last two terms 3 and 2 are co-primes, no common factor is there. So 1 is taken common. When there is nothing common, we take out 1 common because 1 is the common factor for everything. Then 3x plus 2 remains. The third step is the last one, that is 3x plus 2 common, and then 4x plus 1 remains. Thus, 12x square plus 11x plus 2 is obtained by multiplying 3x plus 2 and 4x plus 1. See children, write fourth step as the third one and third one as the fourth one. Now let us see these factorization. In what way these factorizations are different from the before one. Now here the first sum is 49a square plus 70ab plus 25b square. Here your vision should go to the perfect square numbers. In our identity there are two perfect square numbers, x square plus y square plus 2xy. So, he and both should be positive. Here 49a square is a perfect square term. 25b square is also a perfect square term. So, we got a and b here. Instead of 49, I am writing 7a whole square. Instead of 25, I am writing 5b whole square. So, we got a square plus b square plus 2ab we'll write. Inside the bracket of the first term is a, inside the bracket of the second term is b. So 7a square means a square, 5b square means b square, plus 2ab means 2 of 7a into 5b. 2 7s are 14, 14 5s are 70. So the above polynomial or trinomial is in which form, children? A square plus b square plus 2ab, which is in which form? A plus b whole square. So we can write it as 7a plus 5b whole square. 7a plus 5b whole square means the same polynomial is multiplied 2 times. So the factors of 49a square plus 70ab plus 25b square is 7a plus 5b in 7a plus 5b. So this is the way we factorize if the given polynomial resembles the product of the identity. Now second one is 9 by 16 x square minus y square by 9. So what we see, 9 is perfect square, 16 is perfect square, x square is perfect square. Now second term, y square is perfect square and 9 is also perfect square. So it is in the form of a square minus b square. So a square means 3x by 4 whole square minus y by 3 whole square. So what is the identity for that? A square minus b square is a plus b into a minus b. First term plus second term into first term minus second term. 3x by 4 plus y by 3 into 3x by 4 minus y by 3. So 9 by 16x square minus y square by 9 is obtained by multiplying 3x by 4 plus y by 3 into 3x by 4 minus y by 3. These are the factors. Third one is t square minus 2t plus 1. Here also there are two perfect square terms and both are positive. So let us see middle term we get it as 2ab or not. So we first write down t square, then we have written plus 1 whole square. So a is t and b is 1. Minus 2ab term when we write, minus 2 into t into 1 we get. So this is in the form of a square minus 2ab plus b square, which is equal to a minus b whole square, where a is equal to t and b is equal to 1. So t minus 1 whole square is equal to t minus 1 into t minus 1. So children, here the factorization is easy because the given trinomial resembles the product of the identity. So the factors of t square minus 2t plus 1 is equal to t minus 1 into t minus 1. Now the fourth one is x square plus 3x plus 2. Here you can understand that the fourth identity, the middle one is, the last one is product, the middle one is sum. So this is 2 into 1 and the middle one is 2 plus 1. So this is in the form of x square plus a plus b of x plus ab is equal to x plus a of x plus b. So we'll write this as x square plus 2 plus 1 of x plus 2 into 1. So here a is equal to 2 and b is equal to 1. It is in which form now? X plus a into x plus b. So x plus a means x plus 2 into x plus 1. So the factorization is x plus 2 into x plus 1, or in other words we can say that when we multiply x plus 2 and x plus 1 we get x square plus 3x plus 2. Thus, we have completed today's class. The chapter is remaining. A lot of work is there in this chapter. First of all, you write down every slide as your classwork, and then open your textbook and next exercise 2.5. Whatever you are able to do, start doing and see that whether you have understood or not. Thank you, children. Do your work sincerely.